simplify each complex fraction, reduce to lowest terms. Now, sometimes when we have these complex fractions that have multiple terms in either the numerator, denominator, or both, it is quicker to use another technique. And so what we do is first we find the LCD of the entire complex fraction. So, looking at the denominators that I see in this first example, let's see, we have a 2/5 minus 3/10 over 4/5 plus 1/2. So focusing on the denominators, 5, 10, 5, and 2, I can say that the LCD of this entire fraction is 10. So what I'm going to do is multiply both numerator and denominator by 10, and I can think of it as a 10 over 1. And this is legal because really what I'm doing is I'm multiplying by a special form of 1, right? Because 10 over 10 is 1. Applying the distributive property in both the numerator and denominator, I get 2/5 times 10, or 10 over 1, minus 3/10 times 10 over 1 over 4/5 times 10 over 1 plus 1/2 times 10 over 1. Now, going through all the multiplications here and reducing all the fractions, this gives me, let's see, 2/5 times 10 is 4, minus 3/10 times 10 is 3. Denominator, 4/5 times 10 is 8, plus half of 10 is 5. And so we get 1/13. Alright, so if you have a complex fraction where there are multiple terms in either the numerator or denominator, it's usually easier to use this technique instead of doing the additions and subtractions first and then the division. Alright, so let's see another example. 5 plus 2 over n divided by 4 minus 1 over n. I only see one denominator, so the LCD for this expression is simply that denominator. So I will multiply both the entire numerator and entire denominator by n over 1. And I will apply the distributive property. So I have 5 times n over 1 plus 2 over n times n over 1 over 4 times n over 1 minus 1 over n times n over 1. And so let's see, 5 times n is 5n plus 2 over n times n over 1. The n's reduce out, leaving 2. Or in the denominator, 4 times n over 1 is just 4n. Subtract 1 over n times n over 1 is 1. So we get 5n plus 2 over 4n minus 1. Now we should check and see if we can do any factoring here, and in this case we can't. So we'll stop with that exercise. Alright, in example C we have 1 minus 4 over a over 1 minus 16 over a squared. Alright, so focusing on the denominators, we see a denominator of a and a denominator of a squared. So we only have one distinct factor, which is a, but we see that we have to choose the a squared, choosing the higher exponent. So the LCD is a squared. So let me multiply both numerator and denominator by a squared over 1. And so then this would give us equivalently 1 times a squared over 1 minus 4 over a times a squared over 1 over 1 times a squared over 1 minus 16 over a squared times a squared over 1. Alright, we go through the multiplications and reducing. This would give us a squared minus 4a over a squared minus 16. Now, we can do some factoring here. All right, in the numerator, a squared minus 4a, I can take out a common factor of a. That's a by a minus 4. In the denominator, a squared minus 16 factors as a minus 4 by a plus 4. So I see that there is a common factor of a minus 4, and I can remove it, leaving a over a plus 4.